Well, hello once again, and in this video, I'll be talking about differentiation, basically the chain rule. And if any of these videos have been helpful to you and you wish to ask any questions, you can send the questions directly to my email. I'll be more than glad to answer them. Okay, so basically the chain rule is a kind of collective, or yeah, it's a kind of collective. I won't say generic, just kind of collective rule which says that the y, the x, it makes use of the u substitution. It can be applied to trigonometric functions like sine rather, cos and tan. That's sine, cosine, and tangent. So it's dy dx is equal to dy du multiplied by du dx. Now this u is an external I won't say an external, it's actually an internal constant because it's gotten from the equation itself, or should I say from the variable itself. Yeah, so this is made so, well, I say this collective because if I cancel this and cancel this, I'm left with dy dx, which is originally what I have here. So no no strings attached, no long method. So let me use this for, let's say, I ask you to find the derivative of sine 4x. Basically my u is going to be equal to 4x. So if I put my u equal to 4x, therefore y is equal to sine u. Now if you noticed here, y was being measured in terms of x, but here it is being measured in terms of u, rather it's being measured in terms of u instead of x, so that if I'm to find dy du is going to be cos u. Yes, maybe in the following videos I'll show you why if you differentiate sine of any value you get cos, and differentiate cos of any value you get minus sine. I'll also do that for tan to show you why you can get sec square x. So now I have my dy du to be cos u from here. Now this is my u, so u here is being measured in terms of x. So differential of derivative of u, that was u du dx is going to give me, but differentiate 4x, I get 4. Remember from the power rule, power come down, power go up, minus 1. So 1 times 4 is 4, and 1 minus 1 is 0. So I have 4 times x raised power 0, which gives me 4. So putting this into this equation, I have that my dy dx is equal to, what's my dy du? Cos u, multiplied by, what's my du dx? 4. So this gives me 4 cos u, and this gives me 4 cos, what's my u? My u is equal to 4x. So that's the derivative of sine 4x. If I even have if I have y is equal to 3x squared, I can also apply the same thing. If I have, okay, let me try with a cos. Y is equal to cos 5x squared, and you are asked to find the derivative of this. Is simply going to be, I'll put let my u be equal to 5x squared, so that y will be cos u. That's all I need. Dy du, because here y is being measured in terms of u, will give me minus sine u. Now when differentiating sine of any value, you get cos of that value. When differentiating cos of any value, you get sine of that, minus sine of that value. So this is minus sine u. That's for my dy du. Now for my du dx, I get, by differentiating 5x squared with respect to x, it gives me 10x. That's because power come down, power go up minus 1 gives me 2 times 5 raised to power 2 minus 1, so it gives me 10 times x raised to power 1. Now putting this and this into this equation, note I can also rewrite this as okay, let me just leave that for another day. So putting this into the equation, I have my dy dx to be equal to, what's my dy du? Minus sine u multiplied by my du dx, that gives me 10x. So this times this gives me minus 10x sine u, which is equal to minus 10x sine, what's my u? 5x squared. Yes, I can still ask you to find the second derivative of this. This is just the first derivative. I can still ask you to find the second derivative. If you have to find second derivative of this, it's still going to give me, let u equal to 5x squared. So that my y is equal to minus 10x sine u. Then my dy du is going to give me minus 10x cos u. That's the differential of that. Then my du dx will give me 10x. Now if I'm putting that into the equation, I would have that my dy dx is equal to, now my dy du gave me minus 10x cos u multiplied by my du dx, that's 10. That's 10x actually. 10x. So putting this, multiplying them together gives me minus 100x squared cos u, which is minus 100x squared cos 5. Sorry, this is the square x squared. So this is second derivative, which can also be known as y prime prime, because this was my y prime. That's my dy dx. It was my y prime. So if I also have my y to be equal to 3x squared, I can simply put my u to be equal to x squared, and then my dy du will be equal to the differential of 3u, which will be 3, and my du dx, this is u, will be equal to 2x, that's power come down, power go minus 1. So if I'm putting this together, it gives me my dy dx to be equal to dy du 3 multiplied by du dx, as 2x. This gives me 6x. So if I do that directly here, I still get 6x because power come down, power go minus 1. That's 6x, 2 times 3 raised to power 2 minus 1. So it's still the same thing. Why? Because as I explained earlier, if these two cancel out, you still get the original. So that's just the basic thing about chain rule in differentiation. Thank you so much.